an event that IBM, together with a number of speakers on the phone today, will be hosting at our e-government in Washington, D.C. on 14th and G on September 28th. It's called the Predictive Governance Forum, and it's bringing together some really exciting system dynamics models that have been developed for public sector clients in Washington and around the United States to illustrate the fantastic work that's being done in this field and to paint a vision of how we at IBM think that this work can be leveraged to really improve public policy making and the future on how we can improve outcomes in the United States and around the world. So I have a short introduction today. I'm going to talk a little bit about what I think predictive governance is and what it means. And then we're going to have 3 examples from folks on the phone illustrating some really fantastic work that's been done at the Veterans Administration, at the Rio Grande Water Basin from Sandia Labs, and at the Mayo Clinic. And then I'm going to talk a little bit about the future of what I think policy simulations will look like and introduce more of the topics that we'll be covering at our event on September 28th. So this call is really designed not to go over everything we're going to discuss on the 28th, just to introduce the key topics, because I realize that this information is complicated and folks may want to understand it better to get context for what we'll be talking about and what this means. Before I continue, I want to take a moment just to introduce the speakers who will be talking today. So in order of the agenda, Isa, could you start?
You have my introduction, right? Okay.
All the charts are in here. I just want to start by acknowledging the other speakers and letting you introduce.
I'm Isa Baron from Worcester Polytechnic Institute. I'm a professor of mechanical engineering, and I am part of the Healthcare Delivery Institute, HDI, at WPI. And we have been applying system dynamics to model healthcare delivery processes.
Great. Len?
Hi, my name is Len Malchinsky. I work at Sandia National Laboratories in Albuquerque, New Mexico. And by training, I'm an economist and a software engineer who, I guess, fell in love with system dynamics. Our group does a lot of work around the world, primarily with resource management. So we're talking about water, mineral resources, and more recently working in the energy-water nexus and global climate change using system dynamics.
Great. Jim?
Hello, everyone. I'm Jim Rogers. I'm in Rochester, Minnesota, and I was introduced to system dynamics at a course at MIT in 1985 and have been doing model-based business process management since then, learning more and more. I did work for IBM between 1979 and 1999. Did some system dynamics application while on assignment in Europe in our CRM days in the early 90s. Left the company in 97 and have been consulting here in Rochester with the Mayo Clinic since then, applying system dynamics to process management. And in the example I'll talk about today, we were able to build models for clinical decision-making for a certain type of patients. Appreciate the opportunity to be here, Steve, and I'm looking forward to the meeting.
Thanks, Jim. So I'm just going to do these guys, Jim, Isa, and Len, have much more content that's much more fascinating than anything I can present. But I did want to spend a little time talking in general about some things you probably all understand. You know, we have 7 billion people on the planet today, and we're doing a really super job of making our world more and more complex. Our world is not becoming simpler, it's not being reduced, it's not being mapped, it's becoming ever harder to understand both the systems we create and the environment we work in. And system dynamics was created 50 years ago by Jay Forrester at MIT as a way of illustrating the complex interdependency of living organisms and systems that human beings create in an ecosystem. Now, today, we understand the idea of an ecosystem just barely. I mean, many of us in the world are still grappling between divine will and cause and effect. But the idea that there might be multiple causes and multiple effects is really very hard to grasp, yet it's so essential to understanding the complexity of the world that we're building every day. And an ecosystem, that idea, well, it's only been around since the late 1960s, 1970s. And systems dynamics, systems theory, is the best way of illustrating the complex interdependencies that exist in modern ecosystems. Now, a couple of years ago actually, IBM embarked on a project that was my introduction to system dynamics and ecosystems. It was a project as part of our Smarter Cities initiative to build a system dynamics, more than a model, a simulation for the city of Portland to help the city understand how even the smallest policy changes in one part of the city might affect every other part. Now, that's an easy sentence to say, but for policymakers, it's an extremely difficult thing to visualize, understand, and anticipate. And every day, policymakers are making decisions without full knowledge of the tertiary consequences of the policies that they create. And we all know that. We all know that from sound bites. We know that from TV. We know that from our own expectations of policymakers that are rarely met. But, you know, what to do about it? What to help make it right? And when I saw this model that was created by some visionary people at IBM and the city of Portland, I thought, this is exactly what we need. We need more systems like this that help illustrate how complex ecosystems that we build actually function, and to see the domino effect of the policies we create before they're actually deployed. What we need today in policymaking is the same thing that application developers use every day: test environments. We need mulligans in public policy. We need do-overs. We need the ability to test and fail privately before we test and fail publicly. And that's where system dynamics offers an enormous advantage to public policymakers today, because it gives them something they don't have: safe test environments to play with policy ideas and to evaluate the tertiary and unintended consequences of even the best-meaning policies on non-human environments, to evaluate human behavior and make sure they're calibrating their policies for the best possible outcomes. Now, I think at IBM, wait, how come it's not going? Can you guys see anything? Oh, there we go.
Yep. It went back.
You know, they say in system dynamics that the structure of a system produces its own behavior. And you've all heard me say many times that people don't know what they don't know. And this is one of the biggest organizational challenges we face: the gap between perception and reality. And I think the strength of system dynamics is the ability to model that gap. This chart didn't come out the way it was supposed to. It was supposed to be circles instead of squares. Nevertheless, I think you get the meaning. Our task is to understand the systems that we've created and the behaviors that they engender, and help people understand what they don't know to prevent those recurrent problems in the future. I think we can model ecosystems using system dynamics to simulate policy and validate outcomes with big data. And that's a little bit what I'm going to talk about in this presentation after we looked at some of the models here. But one of the most influential books that I read as I started to learn about this fascinating field was Thinking in Systems by Dana Meadows. And one of the sentences that she said that I reminded myself as I prepared this presentation was, before you charge in to make things better, pay attention to the value of what's already there. And this summer I attended a great conference in St. Gallen, Switzerland on system dynamics. And I saw some fantastic models from some fantastic modelers in the public policy space. And I asked the question, gee, did anybody ever, present these models to public policy makers in Washington in an aggregate way? do you think people in Washington realize how much wealth, how much fantastic work has already been done in this space? Do they realize how many policies are already created using system dynamics models as a background, as an analytical tool? And sadly, the answer came back no. And so I said, you know, we got to do that, because there's this whole group of people in Washington that are facing historic budget challenges, huge debt, and they're going to have to learn how to do more with less. And technology offers a way of doing that. And they need to know that they're already doing more with less with these tools, and these tools can be automated to produce even better results. I think there's a crying need in Washington for tools like system dynamics models and information integration and big data to help policymakers test their ideas in private before committing them in public, to learn to dynamically steer their environments. And that's what we're here today to discover, in short, as a prelude to the event which will explore this in much greater detail on September 28th. So the first rule is pay attention to the value that's already there. And that's why I've invited our collected speakers today to introduce you to some of the value that they're already producing. Do I have any questions before we start with the first example?